The overall goal of this procedure is to produce a 0.1 molar solution of samarium diiodide in tetrahydrofuran and use it in the synthesis of the Sm-Barbier reaction with different additives. This is accomplished by first preparing samarium diiodide by simply mixing samarium metal with iodine crystals in tetrahydrofuran under argon. The second step is to introduce the additive to the solution of samarium diiodide. In this case, the effect of HMPA or nickel acac as additives in the Sm-Barbier reaction is observed. Next, the substrates, an alkyl halide and ketone, are added to the reaction flask and stirred for 5 to 15 minutes. The final step is to quench and work up the reaction to obtain the final alcohol product. Ultimately, using a kinetic analysis, it was determined how the mechanism of the Sm-Barbier reaction is altered with the inclusion of the different additives.
This method can provide insight into some of the common issues while preparing solutions of samarium diiodide. Once the synthesis of samarium diiodide is mastered, it can be employed in a wide array of other samarium-mediated reductions.
Visual demonstration of this method is useful as samarium diiodide is sensitive to oxygen, and for this reason we commonly carry out these reactions in a glove box. However, here we will show you that it can be carried out just as easily on the benchtop under an argon atmosphere.
Along with graduate student Kim Choquette, demonstrating the procedure will be Sada, a research scientist from my laboratory.
To begin, flame dry a 50 milliliter round bottle.